All right, welcome everybody. Thanks a lot for taking some time out of your day to come here and watch me talk a little bit or stumble around a little bit trying to model some WordPress data structures into DynamoDB. Several of you guys got back with me over Twitter and kind of indicated you wanted these types of this type of use case, and specifically WordPress came up as kind of a content management system service. And I was thinking, hey, what the heck? I've heard a lot of people talk about why not a serverless WordPress. What would that actually look like? So I thought, let's take a little bit of time and see exactly what would that look like, right? So as with all of the workloads that we kind of run through when we get into these types of modeling sessions, I'm going to go ahead and set my browser up and share that. As we start to look at what are we designing for, right? And that's really what we need to understand is what is the velocity of the workload that we're actually building out for, what are the scales, what is the scale of the problem that we're trying to solve, and obviously WordPress is a hugely a popular deployment platform for websites. There's obviously other alternative content management systems and whatnot, but we've got to understand what is it that this thing needs to really be built for if we're going to decide that what are the best data models that we're going to use to support it. And so let's take a look at that real quick and look at the types of scale of the problem that we're going to see. Real quick here. Do you guys want me to turn up the volume? I guess I could do that a little bit and see if that. Oh, by the way, I have some help this time around. We've got some folks from the AWS team. I'd like to acknowledge the moderators on the channel. We've got you could type /mods. You'll see who we've got. We've got a nice crew of folks to answer questions that you have. Like last week, I stumbled around a little bit trying to do all this stuff myself. This week, I've got some hands on deck to pick up some of that load. So, anyways, let's talk a little bit about what it looks like to have a WordPress a blog and what are the bigger WordPress deployments that we can see, and that just comes straight from some of the sources online that kind of represent who are these guys that we're looking at, and we can kind of get some gauge their traffic. So it turns out that their number one list obvious guy here is really the biggest site is TechCrunch. TechCrunch has an Alexa rank, global Alexa rank, 1,861. That's pretty big. 625 in the United States. It's not a top 100 site. I don't know if you're going to see WordPress deployments in the massively scaled out in the top 10 sites. You're not going to see WordPress running those sites. It doesn't scale to support those sites. It's not really built to support that, right? It's not designed to support that kind of workload. So what does it look like to support some of the biggest customers, which are obviously your whales? And most of the use cases we have for WordPress are pretty small, right? They're not all that big. We'll talk a little bit about that when we get into the average size of a WordPress deployment. But let's talk about TechCrunch. TechCrunch is their biggest customer, or their most notable customer, has probably their biggest traffic patterns. And if you look at that, and we assume that their main sites deployed on WordPress, we've got 12 million unique visitors per month, 37 page views per month, and from a requests per second standpoint, what does that break down to? So we got to run this through some assumptions. So we got 37 million requests. We're going to get our average daily by dividing by 30. More or less, we're going to say that our peak day is 5 times our average day, so we're going to multiply that by 5, and we're going to say we're going to get half that traffic in a 4-hour window. So then divide by minutes, divide by seconds, and then say our peak second will be twice our average during that 4-hour window. Okay, so this is kind of a calculation that, I don't know, it's back of the envelope for sure, but it certainly gives us some idea of what that peak load might be. It gives us a design goal that we're going at, and that number comes out to about 430 requests per second. I have a feeling if we went and talked to the folks who manage TechCrunch site, they'd probably say, yeah, we peak out at 400 or 500 requests per second, maybe more or less. But the reality is it's not going to be thousands of requests per second. We're not that far off here. So let's take a look at what we would need to do to design to a maximum of this load, which is a fairly reasonable amount of traffic, right? It's not millions of requests per second, and that really kind of helps us when we start looking at modeling in NoSQL databases, right? So things get easier when the traffic becomes lower velocity, so to speak. So let's take a look at what that means from a WordPress perspective as we go through these getting a comment to increase the zoom level of browser tabs. Okay, no problem. We can certainly do that. Is that better? Yeah. Okay. So as we start to look at, and I'm showing all these ads and whatnot, but we don't necessarily want to see all that. This is just a post by a hosting service that does WordPress deployments, and what does the space look like across their family of customers, and it's actually quite interesting to look at this because it tells us and they give us some nice use cases for what customers might look like. And so on average, we found that the typical client has approximately 1 gigabyte of data. It's generally broken out across these categories in the system, and your MySQL database is what we're specifically interested in, is how big does that really get? It doesn't get that big. 85 megabytes is actually really, really small, right? We charge, by the gigabyte for DynamoDB, so this is kind of almost free tier, right? Which is actually really interesting when you start looking at it. Actually, I think it is free tier. When you start looking at, what would it take to run your DynamoDB-backed WordPress deployment in the serverless framework? I think we're starting to get an idea of here. It might actually cost you nothing. So let's get interesting about this, and hopefully some people might take, some of you more creative individuals might take some of what I'm talking about today when we get to the modeling and extend it in the ways that we're also going to talk about. Because what I'm doing today is interesting from a modeling perspective, but there is no connector, right? But that will actually operate the way it needs to operate to use the models that I'm going to go through. And it would, this is something that maybe someone could take and start to build those connectors, and we could talk about how you might extend those connectors for, in areas that would need to scale for the even larger customers, and start to do things that maybe WordPress never even thought was possible, because you've got the back-end scalability of Lambda and DynamoDB now to play with, right? So I actually got to be more and more interesting as I started to go through this exercise to see what could potentially be done here, and this is kind of the foundation that we're going to talk about. So, obviously that foundation is the data, the database that drives, a standard default WordPress deployment. Now, you can have many variants of this. There's plugins. There's all kinds of things you can load on your WordPress deployment. We're not going to talk about those. We're going to talk about the core constructs of, a content management system, which are, we have posts, really is what it's all about. But we have users that create those posts. We have users that make comments. Users have various roles and whatnot. But really, when we go to query the system, what are we mostly doing is we're saying, go get me all the posts that match these conditions. And in WordPress, there's a specific, what they call taxonomy, or grouping of terms or categories that define how posts are identified from the from a content structure perspective. And as I kind of broke this down, what it really comes down to is that posts are related to terms, and they're related to terms through these taxonomy relationships that terms have. So terms can belong to many taxonomies. There's really no taxonomy. That what defines the taxonomy is the collection of terms that are all related by the taxonomy name or label, so to speak. It's these relationships that actually define the taxonomy. So, and then posts are related to those term taxonomies, so to speak. So really, posts are related to terms, and they're related indirectly through these various mapping tables, so to speak. And they can have posts can be related to many terms, and terms can be related to many posts. And we'll get into the actual structure of how we represent this when we start talking about how do we model the data, because it's really, when you start to query through these structures and look at the way that WordPress queries work, they basically define an SQL query, a fairly generic SQL query that has lots of filter conditions. And so, we're going to end up doing something similar for, more or less unknown queries, and we might do something that's a little bit more sophisticated for the queries that we know about. And then we might provide some sort of framework to allow WordPress developers to extend, those recognized query sets, so to speak. So we'll talk a little bit about what all that means when we get into the actual modeling of this. But it's kind of important to understand is where are we starting in the stack here, right? I'm not giving you, and we're not going to talk about an implementation of this relational structure in a manner that can be queried with an ad hoc query engine, because that's not what NoSQL databases do. We're going to be mapping these entities, and this is our entity relationship diagram here, obviously. We're going to be mapping mostly the posts, the comments, the users, and the terms into a single table structure that we're going to then index on a couple of dimensions to support these kind of filtered queries that people need to execute. And we're going to rely on the fact that most of the time the data that sits inside of these tables is pretty small. Okay, so it can be very efficiently queried, and most of the time the velocity of queries against this data is actually, again, fairly low. So I have a feeling that when you get down to pricing, again, you go to on demand or you go into most of the time you could be operating in free tier. You're really looking at pennies, right, to really manage these workloads for 99% of your WordPress deployments. And really that's what it comes down to, is that this system is not designed to support the massively scaled out distributed workloads that something like an Amazon would require. It's just, that's not what WordPress is built for. That's not its target customer. And when we build systems and we design systems with NoSQL, that's really what we need to design for, right? Is what is the target? What are we intending to build the solution for, right? So a lot of the things about the complexities of scale kind of fall away when we look at an average data set that's 85 megabytes and segmented across entity types. And so let's talk about what that data model might look like. But to understand what that might look like, let's talk about access patterns, right? And access patterns in WordPress are quite well defined, but everything kind of comes down to these query classes, right? The WP query class, which queries posts, the WP comment query, the WP term query, the WP metadata queries, all these things, these classes that are designed to actually query objects out of the database, and what they are looking to actually retrieve is defined by the arguments that you feed the query generator, right? You create a new WP query, here's the args I want, it generates some query object, I'm going to go, okay, execute that query by calling this have post method, and we're going to iterate on that result set. Okay, that's pretty straightforward. And what we're really interested in is this, right? Query vars. These are the arguments that we're passing in that define the nature of the queries that we're going to run. And here's a lot of the examples of the types of queries that you can run against the parameters that we're actually executing against. And you can see that those parameters map very well to the fields of our entities. So if I'm querying the WP query class, is primarily queries posts. We can query the author, filter on the author elements of the post, and find the relationship between the people who wrote the post, right? There's the post author, when it was written, who wrote give me all the posts written by an author in a given date range, right? And it's actually a very generic class that allows us to specify arbitrary sets of attributes. So who knows what the developer might specify, and these typically are not really good workloads, right, for NoSQL, because again, it's kind of like an ad hoc query engine. I'm giving the customer an interface that says, here's all these attributes you can query, including things like metadata and derived data and all kinds of custom data, and who knows what you're going to enter. And as a developer, you might enter all kinds of things. So this would not necessarily really be a good workload for DynamoDB, except for the fact that we're talking about really small data. And generally speaking, when we query this data, we're going to be doing it in ways that are, potentially, like I said, arbitrary, but in a particular application, not so arbitrary. So if we think about how I might implement a data layer or replace, so to speak, this WP query mechanism or overload it or however you want to define it, what I might do for DynamoDB is say, okay, I've got some set of recognized queries. When you feed me a collection of properties that I have that match a pattern that is defined, I will execute a specific query against a specific GSI that's optimized for that particular use case. This is what we do with NoSQL, right? But if you give me some stuff I don't know, then what I really need to do is I need to query all the objects of a given type, potentially all the metadata for that object or whatever it is. When you define these conditions, I need to collect all these objects, figure out how to at least cut through them on some initial condition, maybe a date range condition. Most of your queries are going to come in looking for things not just by author, but by author and date range, or by category and date range. So that might be a good way to sort my objects. But anyway, what I really want to do is be able to cut through the collection of objects of a certain type and check for values of a given attribute and return the results from that. So with small data sets, we can actually do that pretty efficiently in DynamoDB or any NoSQL databases, any NoSQL database using just indexes and partition scans. So We'll talk a little bit about that when we get into the modeling. So let's go ahead and go there, right? So the first thing we've kind of got here is, again, we've got this data model. This defines our entity relationship diagram. We've sized our workload. We kind of understand, how much, data I'm going to be working with potentially for our average case. I have a feeling that if you look at the median here, it's actually a lot lower than this, and it's or very close to this. It's not certainly going to be. You've got a couple of people who have a large numbers of data, large amounts of data, but you don't have, a large number of people up there. And even those guys, again, when we look at the biggest of the big, don't get all that scary, right? So if you think of requests per second, even at peak, and again, you look at some of these bigger sites, and most of the sites are doing this. The bigger workloads we might expect in a WordPress deployment might be things around comments, queries around users. These are probably bigger than your actually result sets you're going to get from posts, right? I'm probably going to have a lot more users than I'm going to have posts, and that's just going to happen for a long time. Same thing as I'm going to have a lot more comments than posts, hopefully, if I have a successful community. And even those dimensions don't get scary from the amount of data that you might see by object type, that especially when cut down and filtered by post or filtered by date range. And if they do, we can allow for some extensions of this query class to optimize our access patterns, right? So we could say, hey, look, if somebody's querying on a particular dimension that's very painful from our data perspective, a developer might come in and say, okay, I'm going to define a new known query, and for the WP query class that's connected to DynamoDB, and that known query is going to accept query vars X, Y, and Z. And whenever I see a query that has X, Y, and Z, I'm going to use index 1, 2, 3, or 4 with these query conditions, and I'm going to add any extended filter conditions, because if I see X, Y, and Z, I can optimize the query pattern, right? So again, what we're really trying to do is give developers a generic construct to access items across any kind of filter collection or filter set, and optimize for the patterns that they need when they see these types of big data potentially scenarios, which I honestly don't think you're going to see very often. So let's get into the modeling here, and we can actually look at what this thing actually is going to look like. So transition my scene. All right, so here we are in our favorite tool. I love this tool. I have many suggestions for how to make it better, but I love what it is, and we will obviously take some of those suggestions hopefully over time. But this is a great tool for modeling your data. This is the NoSQL Workbench for DynamoDB, and what it does obviously is allows it to define different types of objects, load those into the table, look at how they are organized in the partitions that we're kind of trying to logically create, not only on the table but on the indexes. So let's go ahead and do that. We're going to create our WordPress data model. It's going to describe what a default installation of WordPress might look like with the DynamoDB backend. And obviously someone might hopefully take this discussion, extend it into an actual plugin for WordPress that replaces the MySQL database, but that's not something I'm going to do. All right, so the first thing we're going to do is define a table. Hang on one second. I have a list of items over on my other system here. We're going to kind of start to create as we build this table. And so obviously everything's about a single table. So the first table is going to be data. Data is going to have a partition key. It's going to have a sort key. This is kind of generic construct as you're going to get used to. We'll define what types of partitions we have, what types of items we have. And as a matter of fact, I think what we'll do is we'll go ahead and decorate these things right off the bat with the type attribute, so we can distinguish as we get into, because this was a relatively complex model in the end, and it's nice to actually be able to look at the items on the table and say, oh, it's this type, it's that type. So we're going to go ahead and annotate. And at first, we're just going to go ahead and create these partitions that are based on the entity types that we're going to be using. So let's go ahead and do that. We've got obviously a couple types of partitions we talked about. We have our user partitions. So there's going to be a user ID that's going to define the user partition. And the user is going to have I'm calling it an A record for this model. The A record is kind of my top level attributes that if you look at that users table in our model, it's going to have all of those extended attributes somewhere. This is a user object. Inside of that user object, we're going to have some user metadata. So there's some metadata that's going to be associated to this user, right? And we can have many metadata objects. So the first one, we'll just, metadata object 0. And one of the things we need for metadata is we're going to need the keys and the values for that metadata. So let's go ahead and add there's a couple other attributes. And the reality is we're probably going to be indexing on those keys and attributes, because one of the things we want to do is find all the users with metadata attribute X, find all the users with metadata attribute Y. So let's go ahead and and we might have other conditions or say find all users with multiple metadata attributes, but let's go ahead and create some indexes that we might start using for these guys. Save that. Go back to our table. Add a couple attributes, and since these are probably going to be indexed attributes, we will name them as such. And let's go ahead and add a GSI that uses those attributes. Yeah, I got some questions from some folks about in arrays and whatnot. We'll get into that. There's going to be, some, and there's going to be some, depending on, the nature of the query, there will be some full partition scanning, unless you want to optimize things. And we'll get into optimizing. Optimizing is, in the initial structure we're going to set up, and maybe we should wait a little bit when we get into the modeling, but I'll discuss it now. The initial structure we're going to set up is more or less saying, you know what, get me all the objects in a given type, sorted by some default dimension that we expect we'll see, but we don't necessarily have to see. For generally by object, that would be date range. And we'd say, okay, get me all the objects, say maybe all the posts in the last 30 days that match all of these conditions, right? And all those extended conditions would be provided as filter conditions, and maybe the first pass through posts would be the sort condition could be a date range sort, and say get me all of the posts in a given date range, and then apply some filter conditions to that. Now again, you have to understand the size of the data we're dealing with here. It's not like these are monstrous loads of gigabytes of data that are going to require me to paginate through thousands and thousands of items, right? I mean, a taxonomy in WordPress might contain 1,000 posts, right? I mean, this is not something that's and even over years might generate a couple thousand posts. So to query across the collection of posts in a given WordPress database instance for a given taxonomy is not necessarily going to be something that's all that painful, and this is what we'll start to look at in the system. Now there's ways we'll optimize, we'll talk a little bit about that, but generally speaking, the idea that we're going to support these ad hoc queries with multiple arrays and all these types of properties, like give me all the posts for users that are not in X, some array condition. Not ins are going to require us to do, can actually be executed in single query conditions as an array on a sort key, for example, if it's all date range conditions or whatnot, or again, let's get into the modeling, and then we'll talk a little bit more about the actual access patterns as we start to build this model out. Let's take a look at this first, thing that we're going to be doing. And maybe what I should do is let's go ahead and just create all the partition types, and then we'll start worrying about how we're going to index things, right? So metadata, let's worry about this later. Metadata is obviously going to contain keys and values because these are the custom properties of the object, of the user object that may be defined by plugins we install, could be defined by the system itself by default, could be defined by individuals, right? Think of these as what you're going to decorate your user entity with as far as when you create a user or when a user performs certain actions, right? They might end up with metadata objects that get updated. As we start to build out additional items, what else do we need? You know, users are obviously going to create posts. So let's go ahead and create a post partition for potentially for a given user. So this is, again, posts are going to have some sort of a record. This is going to be a post type object. We're not going to worry about indexing just yet. We're going to create a piece of metadata for that post. Oops. And so this is some post metadata. Again, I'm just putting this type in here so that as we start to visualize, I do like to decorate my objects with some sort of type object, you know, identifier, so that I can do schema validation potentially, you know, understand what types of objects I'm working with when I have at the application layer, how they should be wrapped, what classes should wrap those objects, whatnot. But you know, for this use case, what we're doing is just trying to see what are these objects, because it's going to get a little bit more complex. We'll talk a little bit about the kind of term relationships that a post might have. So let's talk about, let's create an item within the post partition that might be a term relationship. And let's say, you know, maybe this post is in our consulting category, which is the term. And so this would be a term relationship. So this is what it gets defined when you look at that, when you look at the actual schema. Go back and take a quick look at the schema and see where what we're actually building. So if I go and take a look at the actual WordPress schema, what I'm trying to construct here is, see, posts have this relationship to terms, right? So I just kind of built the term relationship here, and I said, you know, there's a term called consulting that we're related to, right? And you know, we're actually related to this term taxonomy, but we'll get into that. We don't actually, I model this kind of indirectly at some point by creating an index, but you know, right, what we're really related to is this term, right? This post was created in the consulting term. That consulting term lives inside of a certain taxonomy structure, but that's more or less transparent to the post, right? The post only needs, I know that I'm related to consulting. So that's what we kind of created in that term relationship. Yeah, we'll be posting the final model, absolutely. I'm going to make that available for people to download. So, see if we can get a Twitch channel, a link on the Twitch channel for that. All right, let's get back to Workbench. So if we go back into Workbench here, we've got now what we are created is this post. Post has this A record. Another question here. What's the significance of having SK as an A record? An A record is really just kind of the top level item that describes the object, right? If you think about, let's go back to our, real quick, to our schema diagram here. If I look at the A record is this row, right? It's all this stuff, more or less, right? It's going to, not always, right? We might have defined, you know, some of these things on the relationship or on the edge. But more or less, some of the items in that partition might be metadata, as we described. But if you think about it, what we're doing in the model is we're creating a one-to-many relationship between the post and the metadata that is, you know, and that's what these things are. So if I go back to our data model here, if I look at the aggregate view of what I've just created, what I've got is some partitions that have some items in them, and there's a one-to-many relationship between the user, and this is the A record, which is that user row from the users table. This is the first, you know, metadata item that lives in the user metadata table. There might be many of these items, m#0, m#1, m#n, right? There's just all this user metadata, and all that data more or less has this kind of key value, you know, type of pattern when you look at that actual metadata, right? User metadata, it's got a key, it's got a value. Now these values, long text, it's big, it's huge, it could be gigabytes, but the reality is that the values in this metadata are relatively small. If we have big objects here, obviously we would want to reference those in S3, store those up in S3. There's already plugins to store your big file objects up in S3. And I don't think that in WordPress databases you would find many metadata items that have, you know, extremely large values, or many of these rows in this database. Although again, I'm not a WordPress guru, but everything I'm looking at tells me these are small objects. Most of these things should be, you know, 1 kilobyte or less, probably a lot less. You know, again, we can do batch queries of objects that are small, and it doesn't cost us a lot in the way of RCU. I mean, if your average post is, you know, a couple kilobytes, and I'm not talking about the binary large objects like images and all that stuff. I'm talking about the text of the post. Even then, a couple kilobytes might be stretching it for your average post. You know, to read 100 posts, for example, might cost you, you know, what if I'm getting 2 posts per RCU, might cost me 50 RCUs, and I'm doing how many requests per second on the average WordPress blog, right? I mean, this isn't really crushing it type of performance, and the thing I'm relying on here is the fact that, you know, a pay-per-use service like DynamoDB gives you an enormous amount of flexibility with the amount of, you know, efficiency that you have to play with. For example, I mean, I can consume a lot of resources for a short period of time and not pay much, and that's really what the crux of this is you got to look at what is the workload for WordPress. It's small, and what are the data sets? Well, they're small, and so if we're small data sets and we're, you know, then I don't need to optimize for the read, because the reads are very cheap, even if I have to do full scans of the data set to produce filtered results. Now, again, as we start to scale the system and we start to look at this and say, well, geez, this is becoming a pain point, and this is where, you know, a WordPress developer for DynamoDB, for serverless WordPress, might look at and say, okay, I've identified a pattern here that's putting data pressure on the system, right, that's going to get me expensive, and I can see this happening. Then what we can do is we can create this, what I said was a recognized query, where if I see a particular collection of query vars, then I know exactly which interface, which, you know, GSI, or I know exactly which special query I can execute to avoid those full partition scans. So you're kind of leaving it up to the developer to decide, when do I just do a generic query across this kind of bucket collection we're going to create here, and when do I do, you know, specifics. And we'll get into that in the model. I'll show you not just this generic construct that we can query. That's what we'll show you first. But then we're going to say, okay, for specific patterns, somebody says, get me all the posts in the last 30 days. Well, you know, what's the best way to do that? What's the best way to get all the posts in the last 30 days by authors in this list? You know, things like that, right? You know, we'll start to create some models that'll give us some more specifically optimized patterns. But what we need to kind of get our heads around here in the beginning is that the initial, you know, I don't know what this query is going to be a more or less a scan of the partition that contains all the objects in a given type, or in a given you know, collection of objects that you're interested in, you know, querying through. Okay, and honestly, if you look at the SQL that's generated by WordPress, I guarantee you it's not optimized SQL that comes out of WP query. When I go, hey, give me, give me a new WP query, what comes out of this thing is, you know, a relatively straightforward hierarchical join between the entity tables that they have defined with a bunch of filter conditions. And this could easily be happening on on attributes and dimensions that are not indexed, but they don't care, because again, they know their data set, they know their customer. It's not that big, it's going to cause a lot of problems, and there's all kinds of optimizations that you do if you do need to scale your deployments, right? And this is where we start to get into you know, what the cost of running a single site versus a collection of sites versus, you know, customized code to optimize the workflows of a given site. And it's not so different when you start looking at, you know, optimizing WordPress, you know, deployments, right? It's code, and code can always be optimized. So anyways, let's get back into the data modeling. All right, so we've created a couple partitions here. Let's go ahead and create a few more. We've got users, we've got posts. Hang on one second, my other screen keeps on logging out. So we got users, we've got posts. We're going to have, you know, comments that we're also going to see in the system. So let's look at, you know, comments. Comments are also going to have some metadata. They're going to have an A record that describes the comment. And again, these A records are the rows. Think of them as the rows from the top level entity tables. The metadata items are simply the rows from the associated metadata items table to that entity. That's all clear in the diagram there. Users have user metadata, posts have post metadata. And this is what we're doing. We're creating this one-to-many relationship that exists between two tables. We're actually inserting those rows on the same table, and so you can already see how some of the basic access patterns are actually, supported right out of the box, right? I mean, I can get all the metadata for a user, get all the metadata for a post, get all the post information. I can query a post and get, the hierarchy of relational data that's associated with the post, which is, all of the, post information, the metadata information, the term relationship. And when we get into thinking about how are we going to project the term relationship and the data into the term relationship, we can certainly denormalize some of the term metadata into the term relationships, right? So if you look at that table, we kind of related through multiple tables to the term, but I can project all of that data from that term table into these term relationship items so that when I query by post ID, I don't have to go down through this hierarchical relational structure. And the reality is you don't change those terms. That's relatively immutable data. It does not change very often. And when it does, I can just go ahead and clobber all these term relationship items with the updates. I don't need to update each individual item because this is really just a static representation of the actual term itself. It's a one-way copy. I will never be updating these items within the post ID partitions. If I update the term, I'm going to do it inside of the term partition. We're going to talk about that now. So let's go ahead. Since it's comments, we have comments now. We're going to have terms. Let's go ahead and just create actually a few comments because we're probably going to want to see, what it looks like to do some sorted collections. So let's add comment 1. It's going to have the same kind of structure. Have an A record, it's going to be a comment. Come on, give me that. And we're going to add one more. That'll be a metadata item. It's also going to be a comment. Metadata. All right, so we're going to save that. So if we look at our aggregate view, we have a couple of comments, we have a user, we have a post, we have a couple of comments that might be on that post. We'll show you how we're going to get all that. And the reason why we're setting these partitions up like this is because when you look at those APIs in WP Query and you look at the stock methods that are available for users, there are all get user by ID, get post by ID, get comment by ID, so on and so forth. So, these types of patterns are supported straight off the table. Get me all the metadata for a user by ID, things like these. These are all, satisfied straight from the table. And as we start to extend the model, what you can start to see is, hey, if I want to query for user data by metadata value, then maybe I can project some of the user data onto the metadata items again when I create these things, because the user data doesn't get updated very frequently, and these types of optimizations could be advantageous when I actually go get all the metadata items that match a given property. I might also want to return some of the user data, maybe their login name or things like that. I can project that data into the actual metadata item itself. So that's when we get into actual indexing, we can see how projections and denormalization of the data can help us. Got another comment folks want to ask. Why comment ID and comment ID 1? Because we're creating two comments, right? So if you look at the table, what we've got, let's see, go back to Workbench here. This would be one comment, this would be another comment. So if I want to select my comment ID, you could say it's comment ID 0, comment ID 1. As a matter of fact, why don't we do that, make it a little more clear. I'm representing more than one object here. Since we only have one user, I just said it's user ID, but since we have more than one comment, I'm creating two comment partitions. So now when I look at this, you'll see it's comment ID 0, comment ID 1. They're two different comments. They both have some metadata. Who knows, maybe they were created by the same user. In this model, that's what we're going to assume. User created the post, this user created the comment, this user replied to his own comment. That's what we're going to kind of show you. As we get into the other types of partitions that we have on the table, there's really the last one is the term. And let's go ahead and create those term items. So we're going to have a couple of terms that we're going to create, and they're going to be our consulting category and our let's say services and then consulting. Yeah. So we've got a services category, and maybe we've got a consulting category or term, because that's really terms and categories are almost interchangeable. As a matter of fact, they are interchangeable. And these guys belong to one of the default taxonomies in WordPress. We'll say it just belong to the categories taxonomy. Okay. And so what I've done here now is we're going to go ahead and say that maybe one of these terms has some metadata. Let's say that this should be consulting. Maybe the consulting term has some metadata. And we're going to use that same kind of structure here. And so this is a term. This is a term. This is some term metadata. Okay, so let's save that now. We can look at our aggregate view. I've got user ID partitions, I've got post partitions, I've got comment partitions, and we have a couple of term partitions, right? One of those terms has some metadata. And we're going to go ahead and use the sort key to define the actual taxonomy that these services belong to, or that these terms belong to. So the services term belongs to the categories taxonomy. If I were to add it to another taxonomy, I would duplicate this and create a services category or term inside of another taxonomy, right? So one of the default this is so confusing why they did this. One of the default taxonomies in WordPress is the categories taxonomies. That's what we're assigning everything to. Okay, so let's see. Hopefully you'll get some insight on WP options. So WP options is from, again, I haven't really dug too far into the WP options table, but as far as I can tell, that's really more of a lookup dictionary of options that you get for a particular site or have available for plugins or things like that. So most of what, again, from the beginning of the session I described, my focus here is going to be on the main entities, which are users, posts, and comments and taxonomies and terms. The options I'm looking is more of a key value lookup, an index of, like I said, dictionary of settings, so to speak. So those patterns should be relatively straightforward, puts and gets, more or less. Unless I'm wrong, I'm not a WordPress guru. One of the things I could certainly say is if anybody really wants to take on the project of creating a WordPress plugin that does some of what I'm talking about today, I'm happy to make myself available to consult on that project. I'm not going to contribute as much, very much, but I would certainly be happy to talk about how could we deal with data modeling, how could we deal with the process. Okay, let's go back to the visualizer. Okay, so now we've got, again, different partitions on the table: user partitions, post partitions, comments, partitions, services, consulting, and so we can take a look at, how now are we going to actually start to look at these things across all of these various categories. And to do this, what we're really going to be doing is creating what we call a right-sharded GSI. So the first GSI we're going to do is we're basically going to right-shard all of these items on, some particular, dimension, which would be by type. And so in this particular case, what we could look at and say, again, we're not looking at volumes of data here for our average, WordPress deployment. We're looking at a pretty small amount of data. So do we even need to right shard these GSIs, this GSI? My assumption is that not, unless, there's a particular reason that we see some dimension of scale that could cause the kind of pressure on the system that would exceed a single partition GSI by type. So I'm assuming we're not going to see that, and certainly not for the average use case. We can have some sort of configuration setting in the plugin that might say expect X number of users, expect X number of posts, things like this. where we could start to say, okay, if you're going to expect 65,000 users, then maybe I want to do some right sharding, because when I go to select all users of a given type, I'm going to be scanning a lot of data. So we can certainly set this up, but again, my feeling is that for the average use case for WordPress, there's not going to be a lot of need for right sharding. So maybe the first thing we're going to go ahead and do is just go ahead and create a by type partition. So these are users, objects. Hang on 1 second. These are user objects. These are user metadata objects. We've got, and we're going to go ahead and make the key of the user metadata, the partition key and the value. And so I would say give me all the users that have a user metadata key of X value. We're going to say let's go ahead and add this, would be potentially the user type. I don't know if users by date might make sense. Give me all, but again, we would look at, generally speaking, as I started to look through the API from WordPress, I found that user queries are more by type than less by date. Posts are more by date and filtered by various categories, so on and so forth. If we look at the post partition, we would have these again sorted by date, makes the most sense. So this might be just today's date. And let's look at what else we want to put on this partition or on this GSI. Would be maybe the term relationship, maybe the post metadata. So let's go ahead and say PM key. And then let's look at the term relationships, and we would put this into the post. There's no 0 to n. I mean, again, it depends on how we want to categorize this. Maybe it'd say get all posts with the term relationship of X. We could also put all this data in a post, and it might actually be better to put all this data in the post condition, because what we could do is say, and how might I want to do this? I might want to say, yeah, this might be this might work a little better. So I get things by date range. I could get things by multiple key value conditions, as filter conditions. I can start to play with these things in the dimensions that I want to query them. Let's talk about how we want to index these term relationships. Again, do we want to do these by date? Give me everything. Yeah, probably. Give me everything for the consulting that has a consulting term relationship within this date range is probably very common. So what we're trying to do is structure these initial keys so that we can take paths and cut a swath of relevant items, relevant term relationships, relevant objects, that we don't necessarily have to scan every single post in the system. So, but if we do, it's not all that painful. I mean, I could theoretically, depending on how much metadata we're sticking in the posts, and if there's too much metadata that we're sticking in the post, maybe I'll execute a parallel query. I'll say, give me all the posts in the last, that match this date range. Give me all that have these multiple post metadata conditions. But let's assume that, we have enough. We don't put that much metadata on our posts. We don't really have that many posts that we're putting into the system. I mean, like I said, a couple thousand posts would be a large, WordPress deployment, a large WordPress site, and that the metadata that we're associating these posts is relatively small. So that if I go query across, all posts in the entire in the taxonomy, and maybe that's where we would start to sort this thing on. is when we start to look at taxonomies. But really, what we're kind of indirectly getting taxonomies off these term relationships. But what I'm trying to do is knock this list down to a list that makes sense, rather than having to store everything, right? So if we go ahead, let's go ahead and update the rest of those items. These are comments. We're going to update comments on date as well. And this could be a key value for comment metadata. Now this is the area of the whole system that I would start to think might give us pressure, right? Comments, you get a lot of comments per post. Busy blogs give me lots of comments per post. And again, I'd leave this up to the developer to determine whether or not the best way to query for comments is this way. It might be that you're going to have some, known queries that you would define, right? Well, again, we'll get into some of that when we start saying, well, it'd be more efficient if I had lots of posts to get all my posts by date without having to query this particular structure that I'm building right now. And for those particular sets of key conditions or filters, we would build specific GSIs to support those. Again, let's go ahead with the date. Let's go ahead with key value. And then our terms are going to be indexed. Now here in terms, we got a lot of use cases that give me all the terms for a given category, give me all the terms below a given term within a category. And so in here, what we're going to actually do is index our terms by path within the category. So we would say this would be /services. This would be the taxonomy that it belongs to as categories. And the consulting term belongs inside of services. All right, so, and what's going to end up on this guy is our ability to say, okay, let's now look at our aggregate view. And if I look at the GSI, I can query by term, by category. I can, we want to go ahead and update our user metadata object. And again, I don't know if these are the right answers, for as far as we're setting up these indexes. I would want to work through and maybe iterate on these particular selections for our default index, but the object, the repository we're building here is all users and metadata end up in the same partition on the GSI. And if I have to, I can give me everything from GSI 1 that starts, that has a partition key of U. It gives me every single object. It gives me all of the users. It gives me all of the metadata associated to those users, and I could filter that. And this would be the most grossly inefficient way to query this partition, would be to say, give me everything and filter on n number of conditions. Now, if the average user's WordPress blog has 100 users or even 1,000 users, that's not going to be an expensive query, and if it doesn't run frequently, it's not going to crush the system. So you as a developer would look at that and say, does that make sense to query my user partitions this way? If you only have 100 users, you only have 500 users, then yeah, absolutely. Maybe even if you only have 5,000 users, okay, what's the average number of users per WordPress blog? These are things that we would start to look at. What I'm finding is not a lot. So, we're building a system that's targeting a certain particular size of deployment that's not a lot, and as long as we have a system that can support kind of a lot, we'll be okay, right? So generally speaking, these types of inefficient queries can work really, really well, and because DynamoDB is a pay-per-use system, and this is the key here, I don't have to build a system that can support a high throughput query or a high cost query at high velocity, or even at something that's going to be able to stand there, that has to stand there all the time, that I'm paying for. I'm building a system that is able to be spun up when I need it, and I pay for what I use, and it's going to be a lot more cost effective to do that. So again, you can see kind of the way this structure sets up, the common queries that I'm going to execute. Give me all the posts in the last 24 hours, right? You know, I could say, give me all the posts that have a given, you know, key value that start with X. I could say, you know, give me all the posts in the last 24 hours, and then maybe what I'll do is I'll project some of the term metadata onto those posts so that I can use extended filter conditions, right, to, you know, be more selective about the initial cut, and then use multiple filter conditions, right? So you might say, give me, you know, a post that has metadata values key 1, 2, 3 and values 1, 2, and 3. And I know that I'm going to execute that query, so I will project those metadata items, those values, metadata values onto the post, because I'm going to query by date. I'm going to filter on those conditions, and that will get me the objects I need. Versus get me the post that has this key, all the posts that contain this key, or contain this key with this value range, right? Then I could make that query and get a very selective query and not have to, you know, cut through by time. So you could decide, and then again, on the post metadata, you can decide how much of the post you want to project. If I want to project some of the post content, maybe a post summary, things like this, so that when I execute these, you know, key value conditions inside of this post partition, I'm going to get enough of the data back that's going to be able to populate my summary result list. For example, here's all the posts, now click on one. Okay, then when I click on one, what am I doing? I'm going to go back to here, I'm going to say get me the post. Select from the table by post ID. All right, so this is a general construct that you can implement within, you know, your WordPress database to, you know, for DynamoDB, the back end, to allow you to basically query anything on any condition set, which is kind of what their, you know, WP query parameters allow you to do. I mean, at some level, I can take, let's go ahead and take a look at this and see, at some level, I can take any of these properties that are being defined, any of these arguments that are being defined, and translate this into a filter condition, right, in DynamoDB. If I can get a selection of posts, users, comments, whatever it is, that match these conditions, then I'm able to satisfy that query, and that's really what we're translating this to. So by default, a WP query turns into a query against this, you know, aggregated partition, so to speak, in DynamoDB that would probably be cut down by date, because most of the time when you're making that query, you're going to provide some date arguments. Again, you got to think about, and you could certainly in the plugin, you would program this. You'd say, do I see date conditions? Great, let me apply a sort key condition on date. That'll give me the 20 posts that match within the last 6 months. All right, then I don't have to go get the 1,000 that I've had over the last 4 years. You see, so there are ways to be able to, and you know that that's the most common way people are going to query posts, so great, we're going to sort on date within the post partition. And that would be a default install. And so every time you see a date range condition, you say, hey, this is a known query, I'm going to query partition by date, and maybe a user then, a developer, could come in and say, I'm going to add additional things to make these things more, you know, interesting. And, you know, one of the things I might say is, you know, I want to get a user history. For example, I want to know all of the posts and comments that a user has made. And so, you know, we have this initial kind of GSI where I could kind of do that. I could query, you know, all the posts. I could query all the users. I could query all of the comments. I'm sorry, I query all the posts. I query all the comments, and I could get everything that was, you know, written by a user. I could do that in parallel queries and merge sort the results, and, you know, here I present the list. But, you know, if I know that the application is going to be getting the user's, you know, activity history, then as I said, a WordPress developer working with the DynamoDB plugin might say, hey, I'm going to define a GSI for that. Okay, because I know that I'm going to be querying this, and, you know, that's important to me, and I don't want to execute 2 parallel queries. I want to execute 1 query. I want to be very selective. So let's go ahead and do that. Let's say, okay, all these items that we're interested in aggregating on that, which are what, posts and comments, we're going to annotate these objects with the user ID, and we're going to aggregate these items in a different GSI. So let's go ahead and do that real quick. We're going to build a secondary GSI. Oops, not a table. Get back, get back. So this guy, we're going to add a new GSI, which means we need another set of keys. So we're going to add our PK1, PK2, or PK2, and SK2. We're going to add a new GSI, and that's going to be GSI2. Let's make this guy GSI1. He's going to be on PK2. He's going to be on sort key 2. And we're going to go ahead and add that secondary index. Oops, nope, let's not do that. Save this. And so now we have 2 GSIs on this table. Let's go ahead and visualize and update our data. So what are we interested in doing? We're interested in aggregating user activity. So let's go ahead and say, maybe the first thing we're going to do is we're going to say, every time a user updates anything, he's going to update his last updated. He's going to get his last updated timestamp updated. So we're going to go ahead and post a date in there. All right, and what else we need to aggregate? So we've got the user element that's going to be always at the top of the list, right? Because every time he does something, that last updated timestamp is going to update. So he's always going to be at the top of the list of the user partition. Next thing that we're going to do is we're going to annotate posts, right? Posts need to be annotated with user ID, and they need to be given. They need to be given a date. Let's go ahead and do that. So let's go ahead and then what else do we want? We annotate comments. Comments also need to be annotated by user ID. And we want to give those a date too. That's their, that's the deal with those. Okay, we got another comment, don't we? We got 2 comments, I thought. Yes, we got 2 comments. So the user came in and he responded to his own comment, let's say. And so let's go ahead and save that. And now if we go back to our aggregate view, let's say a query comes in and it's got all the conditions on the query that are maybe if even it could be, where I'm looking for all the activity of a given user, right? So if you look at how that might structure, I don't know how you would structure that query with WP query, but there's certainly there might be a way to do that without executing parallel queries. I wasn't really studying it long enough to be able to figure this out. It seems to me that the query constructs they give you are all by entity type, and they're on dimensions of entity type and maybe relationships between entity type. But if you want to retrieve like a whole bunch of entities, like give me all the posts and comments that a user made, I don't know if they actually give you the ability to do that, but this is an example of how we could produce a view like that in DynamoDB, where maybe a WordPress developer in DynamoDB has option to a set of queries and capabilities that don't even exist yet in WordPress. I mean, because I can issue queries in DynamoDB that are going to bring back multiple entity types, right? I could say, hey, give me all the activity for this user in the last 30 days. And that's, something that I think right now in WordPress might require me to execute, multiple loops and parallel queries across multiple entities and, do some kind of data manipulations. And this is what I'm talking about when you say that I say there's no optimization inside of the WordPress, implementation for what I can see, because they have to kind of write this thing to be completely generic. My suggestion would be that maybe for some workflows, I don't want to be completely generic. And this is where we could, extend those query objects to bring back potentially collections that are a date-ranged collection of user comments and posts over the last 30 days without having to execute parallel queries, right? I mean, I don't know. I'm really kind of getting out there and suggesting some things that could be done. We might go ahead and do the same thing for posts, right? Where I want to get the history for a given post, what happened in a time-ordered list of comments and things. We can certainly go there and say, okay, let's go ahead and start to annotate all of these items on different dimensions, right? We can say, let's say if we're doing a post, I might want to add another GSI. I don't necessarily know if we're going to do that right now. We're kind of running a little bit. I was trying to keep this one to a little bit about an hour. I will post the additional model that I have for the rest of the kind of patterns that I put out there. It's a little bit more rich than what we've kind of put together here. But let's go ahead and open this up to like questions. Oh boy, it looks like there's a whole bunch of stuff that I haven't paid attention to. And actually, no, that's not true. I've been seeing. Okay, so got that, got that. Got that. Okay, okay, so similar to last week's blurber, but if you wanted to model top comments, top contributors by post in WordPress and assign them some special user status, if maybe greater than 100 likes, greater than 1,000 likes. Oh yeah, sure. Okay, so get me all the. Yeah, this is a very, and let's go ahead and go through this use case. Very worthwhile to talk about. So again, here we've got a particular use case that says get me the most popular, and that's certainly one of the, actually I think one of the standard options and standard access patterns you get from WordPress is get me objects by count, right? And if you look at the WP query, there's a section on count objects and count parameters that you can put in, and one of the things that they do in WordPress, let's go ahead and show you that real quick. When you look at the actual schema, and let's transition. So if you look at the actual schema here in WordPress, there's the comment count, right, is actually part of the posts. When they go get the post by comment, it's not like they're running some SQL query that says, hey, count all the comments on this table with a given post ID. They don't do that. They actually, when you add a comment to a post, they're bumping the counter on the post object. So that's actually a top level attribute that exists on the item. That's an indexable attribute. We would include that in, hey, if I want to create a support particular access patterns, get me all the most popular posts, all the most commented posts, these types of things. I would go ahead and support that access pattern directly, and that would be just another dimension in which you would index the post objects. And so let's go and take a look at how we might do that. In this case, what we have is posts that are indexed on 2 dimensions right now. They're indexed by the type and the date. They're indexed by the user, and I believe also the date, right? And so these objects are indexed across they're stored on the table. They're indexed across all our available GSI. So for this particular access pattern, we would create a new GSI, GSI 3. Let's go ahead and do that. Oops, don't delete. That would be bad. And so let's add new attributes, a couple new attributes we're going to need here. And actually this, well, it's really going to be the partition and sort key. But the sort key here is going to be our actual count, right? Our comment count, so to speak. So this is PK3. And we'd add another attribute, which would be SK3. And what we're doing here is we're creating a GSI which has a sort key, which is not, our usual sort key. It's a number, but there's lots of ranks, right, that we're going to be needing to sort on, and different objects are going to be needed to sort on different ranks as well. So it's okay to have a GSI that's not a string sort key. Sometimes it's actually kind of useful to have one of your GSI sorted on number, because like I said, there's dimensions that we need to sort objects on that are numeric. So let's go ahead and do that. Let's create this GSI. It's going to be GSI 3. Come on. The shift key keeps sticking, and so that's going to be PK3. We're going to add the sort key. It's going to be SK3, and so you kind of get the idea here. It's just giving us another sorted dimension, another filter, another dimension on which we can query and filter efficiently. And so let's go back to our aggregate view. Let's look at adding a couple of attributes to those items. And that was the post ID item is going to have now a sorted by type, because you're looking for all posts and you're looking for some count. Let's say he's at 100 views. And so we can go ahead and save that, and let's look at our aggregate view. We can now look at GSI. I'm going to see all posts sorted by number of views or number of comments. I mean, it could be number of views, could be number of comments, could be all kinds, whatever. This could be some custom metadata attribute that you're creating a sorted dimension of all posts, and then you query this dimension and say, okay, I want the top 10. So This is not a high velocity aggregation, right? I mean, number of comments coming across all posts in a given taxonomy or a given site. You could even segregate this by taxonomy. You could segregate this by term. Give me all the posts of given term, depending on what it is you're looking to. And as a matter of fact, I might say you would probably say, let's put term as an extended attribute, which it is, that you want to filter on, maybe, when you say, give me the top end posts by term. You might say, okay, let's go select off of this table, and we know we're sorted by this dimension, and I can add my filter conditions, and then take whatever comes out of that. That might not necessarily be the most efficient way to do that, because we'd have to query the entire partition and then add the filter at the end and then do our own limit. But if you could facet the sort key. Potentially, if you were to, or by going partition #term as the partition key, I could get top end by term, right? So all depends on the workflow that you're looking to execute. And as a matter of fact, one of the things we could do if we want is we have all those term relationships on our table, for example. So I could execute, let's say if I want top end by term, that's what I would do. I would say, okay, as I update my post metadata, my posts, right? I'm going to be updating those counters across multiple items. I'm going to add so this might be, the PM #key, and this could be my count, right? So I would say, if this is a term relationship that I've defined here in my metadata, or, oh, I'm sorry, there's the post metadata down below. That's where I'm kind of messed up. So this is actually the post metadata, right? Let's see, post ID. I'm using a really large font on my screen so you guys can read it, which means that, that it's like play school for me. So term relationship, yes, that's my term relationship. And what I'm really interested in is, hey, give me everything in the consulting category and top end, right? So yes. Right, so let's say so every time I update the counter on post, I'm going to go across all of his term relationships. Honestly, it's not too painful. Most posts only have a few relationships. You can make the decision how you're going to do this. Do you do it inline in your workflow when I update the item? Do I maybe have a streams lambda, that comes back and says, oh, you updated the counter on a post. Let me go, update the counter on your term relationships. I mean, this is all, you can make the decision to do this how you'd want. And one of the other things we didn't really touch on, which is probably worth talking to, but let's go back to this GSI. Now I can see, hey, here's my top end by post type, by type post. Give me top end posts. Give me the top end posts, by consulting, and so on. When you start to get into more complex scenarios, you're saying, hey, I want the top end posts that have, multiple terms, multiple tags, multiple taxonomies, whatnot. Those are not common queries you're going to see in WordPress, right? So, let's talk about. And again, this is about NoSQL databases. You need to understand I'm designing for a specific access pattern for a specific workflow. So let's take a look at the workflows we can expect to see. I mean, I can always come up with a use case that says, but you can't do X, and I could do X better with Y. But it's like, okay, well, how often do you actually do X, right? And so let's talk about, what the needs are and the requirements are of the system is really what we're trying to do here. And the real requirement of the system, from what I can see, is, scan through a small amount of data and produce a set of results of entities that match a certain type with a certain set of criteria, okay? And we can do that very quickly with DynamoDB, very easily, very efficiently, using the data structures I just showed you. And again, as we scale the system, we can decide to do things much more efficiently. Or if I need top end, I need to be able to sort on different dimensions. I need to create, much more efficient query patterns for certain, access patterns. Then we can absolutely support that. So, anyways, that's generally speaking what I've got for you today. I'm going to go ahead and open it up to general questions, and let's just say. So Rick, posts also have revisions which are stored with different post ID. Versioning of posts would be interesting to dig into. Absolutely. There's a use case I hadn't even thought about. That's certainly something that and if I think about it deeply, I'm pretty sure I've run into that type of pattern. I mean, we obviously have a versioning pattern in DynamoDB. There's multiple ways to deal with this. Does that data need to be online? Where can we store that data? Maybe what I would do is potentially maintain a version history table that might have the version history of posts and so on and so forth. So when I version a post, I would catch that version on streams and write back to another data store. Obviously, this is an area where if you version posts quite frequently, it could create some data pressure on those filtered queries. Those when I'm running those, give me all the posts of give me all the objects of type X or all the objects that have these conditions. Generally speaking, those are coming from my active users, right? They're on the pages of my blog. When I'm looking for give me the version history of a given post, that's not usually happening at high velocity anyways. That might be happening from your authors, from your administrators, but it's going to be a relatively uncommon workflow. So maybe those don't even bother optimizing those, right? But that's certainly something that would be worth talking about to more detail, and maybe that's for a future session, or maybe that's for the folks who hopefully listened to this and thought, hey, there's some ideas he's got there and he's not crazy, and I think I know how to make a serverless plugin for WordPress, because that would be a really cool project. Don't get me wrong. I mean, I think that would be a really hot ticket. You've got a very popular content management system out there that runs thousands and thousands of websites around the world, and honestly, when I look at the rate and the amount of data that those things are managing, it's free tier. It's free tier for Lambda. It's free tier for DynamoDB. If we could get all this wrapped up into a form factor that actually just works, I think what you'd find is that you might actually see a flock of users go after it. So definitely interested in working with anybody who's wants to talk about doing that. And with that, I guess we'll sign off if there's no more questions. I'll give one more minute. Does anyone have any more questions that they want to talk about? All right, sounds good. Thanks, guys. Thank you so much. I appreciate all your time and you invested in watching this. And we'll have another one of these soon. I'm scheduled for next week. Hopefully that'll hold. And again, if you have any ideas on Twitter for things you want to talk about, I got some really good suggestions from last week. But anything you want me to talk about, feel free. Drop me a private message, and maybe you'll make the scope for the next session. And I appreciate it. Thank you so much. Talk to you all later.